Up for Elumeev. He's a lead systems engineer, also works at Team Systems currently, and he's also AWS certified solution architect. All right, give it up for Misha.
Hey guys, let me check the buttons. Okay, I just would like to check how many of you have been interacting in some way with AWS. Cool. And what about Lambda? Wow. Probably you'll be teaching me something. Okay, so several words about me. I'm a father of two, and it means that I know how to negotiate a demanding customer. Secondly, I'm married, and I've been married for more than 15 years. And for those of you who are not familiar with marriage, it is a sort of relationship between two people where one person is always wrong and the other one is called wife. Okay. So the main idea of today's conversation is Lambda, and simply because I'm not aware of your level, I will try to catch you up with what I know. And I will, start little by little, growing the speed on the way. Oops. Okay, probably this is no. Thank you for your attention. Okay. So we will start from some sort of reiteration, and probably it will be helpful for both of us. So what is a Lambda? A Lambda is just a way for the AWS to represent a serverless service. And what the heck is the serverless? The serverless is again something that you do not manage. You do not have this overhead of managing the operating system, patching it, ensuring the necessary level of security, and what's on. And as of today, AWS Lambda supports the most known programming languages. And of course, it has some limitations. So those limitations are that the execution time of your Lambda shall be limited to 15 minutes. The second limitation is that the package size should not exceed 250 megabytes. But the greatest benefit is that you actually can bring your container image, and it is limited to 10 GB. Why is the difference? Simply because for the container image, you should provide some operating system and other details. Continuing it, the Lambda may have synchronous and asynchronous invocations. And we'll talk about it, but I would like just to give it a shape, if I may say so. So the idea is that many people think that Lambda is actually a bottleneck in EKS or Kubernetes or whatsoever, maybe it is a container image or Docker container. No, it is a tiny virtual machine. That is why they call it micro VM, and actually under the hood it uses the Firecracker. This is the open source project actually supported by the AWS. What else will we be talking about? We will check the difference between synchronous and asynchronous invocations, and I will try to slightly mention the versioning stuff with Lambda. The cool thing about Lambdas and versioning, that with the versioning you can achieve this, holy grail of blue-green deployment and even canary deployment. Okay, this timeline actually shows the history of Lambda, and as you may see, it started back in 2015, and gradually, step by step, they keep adding additional functionalities. As recently, for example, in 2021, they announced that as of today, you have only 1 millisecond billing quota. Continuing in 2022, they added additional functionalities like function URL. Now you can bring your container image. What's more, you have AWS Graviton to ARM-based CPUs. What's more, you have ephemeral storage, which could be increased up to 10 GB. And continuing with it, it is actually a fair question of when do you actually need to choose Lambda, because we have heard a nice talk about having an EC2 instance, which is pretty fine. So the idea is, for example, comparing EC2 with the AWS Fargate or AWS Batch or ECS test. The idea is that it is something short, something repeatable, and something that you may run in parallel, simultaneously, concurrently. And we will talk about the concurrency limits and how you can track them. But again, I would like to reiterate that the time limit for Lambdas is 15 minutes. Okay, since we are talking about time limits, it is nice to have understanding of the billing process. So the limit is 15 minutes, but actually you will be charged on the time execution for your Lambda. So you may set the time limit as 15 minutes, but actually paying for 3 seconds on that. And the thing with AWS Lambda that it is a RAM-based service. So what it means that usually for AWS you have the possibility to control the CPU structure, the number of the CPUs and what's. But with Lambda, it actually can kind of directly coupled with the RAM. So by increasing your RAM allocation, you allot more CPU or vCPU in our case to your Lambda. Secondly, by default, AWS Lambda goes with standard 512 mega as ephemeral storage. So this is just the space for you in your micro VM which you can operate with. Because the idea is that you have some code, you want to bring it to life, and you may see how it works. And you have additional storage, but what if this storage is insufficient for you? People may say, okay, use EFS. And for those of you who doesn't know, EFS is elastic file system, so it mainly supports Linux operation systems. So you can go with it. But what if your customer, or maybe you, don't want to have this management overhead because, hey, we're going completely serverless. Other guys may say, bring a string, but what if I need this huge speed? So this is when you need this ephemeral storage. And starting as of March 2022, you can increase it up to 10 GB. And actually, by adding these increments and increasing your ephemeral storage, you will be also charged based on that. Another thing I would like to mention is that by using Graviton CPU, based instances, I'm talking about Lambdas, it is claimed that they're 20% faster. So simply because you're paying for the time, you're running your Lambdas, maybe it is a good idea to check your code and compatibility issues. And I would like to reiterate some news that could be relevant to today's talk, and we're talking about several. So the first one is starting from May 2022, there is a function URL. So simply, you have a URL which can invoke your Lambda. It goes with its flavors, it goes with its trade-offs, and we will talk about it. But imagine a situation when you need something from the AWS to your GitHub Actions, and you can add this additional Lambda in your workflow. Secondly, starting from 2021, you can bring your container package. And continuing with this idea, as I have already explained, starting from March 2022, you can increase the ephemeral storage of your Lambda to up to 10 GB. And starting from this slide, by the way guys, if you have some urgent questions, just raise your hand. I would like to be completely interactive. And I will have 2 pauses during my presentation, where you will have the microphone, okay? So the first coupling mechanism for Lambda is something which is called API gateway. And you may actually think about it as a front door towards your Lambda, although it, as usual, goes with some limitations. For example, for Lambda, in this case, you have a limit of only 29 seconds, and I will explain just a little bit why it is so. And the second limitation is that the payload size is limited to 10 megabytes. And for guys and folks who are not familiar with AWS, let me just explain several pictures here. So we have a DynamoDB. This is, again, a serverless representation of the AWS service, which represents actually a NoSQL key value database. And the API gateway we have already described. So why you may need to couple your Lambda with the API gateway? You may think about security concerns. You may think also about different free tier versus paid tier relationship with your customers. Imagine if you have a free tier for your application and you would like to limit the concurrency for free tier, and on contrast, you would like to give all the possibilities for your customers who pay for these services. So these are kind of wonderful things you can achieve by coupling your API gateway with Lambdas. The next thing is the newly announced function URL. So what's the difference? As you may see here on the picture above, you have the you have the API gateway, which you are already familiar with, and you have a Lambda directly involved with a function URL. So obviously you do not have any more this limitation of 29 seconds. Secondly, there is a security concern because hey, there is no anymore this formula, and actually AWS tries to resolve it in two ways. So with function URLs, you have two main options to treat your security. The first one is none. So literally everyone having your function, having your URL can invoke your function. And the second one is the AWS diagram. So the idea is that you may need to store your threads somewhere. And if you remember, I was trying to imagine some situation where it would be useful. And the idea is that you may actually store your credentials in GitHub secrets and invoke them when it's necessary, when you're invoking the new function through the function URL. Continuing it, as you may know, AWS actually trying to promote Lambda and is trying to promote all the serverless technologies. And that is why they have created this AWS toolkit, which can be well paired with Visual Studio Code. And the idea is that it actually helps you to debug your code locally. For instance, if we're talking about Python, the function that you can debug could be a top level, should be a top level function. So we're talking about the function containing the handler method. Secondly, you need to provide the requirements txt, listing all the necessary libraries which are standard for Python. And this is simply because under its hood, AWS Toolkit actually creates a Docker image. So it needs to know what to use. And lastly, you will need to configure this debugger configuration. It is pretty straightforward. You have a link, so you can follow it. This one. And voila, it will work as that. And we will continue with some theoretical part because I have touched slightly a couple of things talking about synchronous and asynchronous invocations, and I would like to explain it to you. So with Lambdas, we have three main categories of invoking it: synchronous, asynchronous, and pooling schemes. And with synchronous, imagine it is just straightforward. You have a CLI request, just run the Lambda, or maybe you're visiting your GUI and click this test button. This is the asynchronous invocation. By the way, API gateway under its hood uses also synchronous invocation. Another thing is, another option is asynchronous invocation. And here, it is like a Lambda is given an order, and if we try to go really deep under its hood, asynchronous invocation actually uses synchronous invocation and an SQS, which stands for Simple Queue Service. And in this case, Lambda is usually given up to 3 attempts to try to do their best to succeed with your request. And if it fails, okay, it fails. And pulling invocation. This is something when you need to pull messages from somewhere. For example, with SQS. And actually the good moment about SQS is that it actually can be part of asynchronous invocation. If you source map your SQS with Lambda, it will invoke your Lambda whenever it receives a message. Instead, for your Lambda, just querying for your SQS whether or not it has something for it. So the next slide is pretty much the same, but here I have a nice picture because I stole it from the AWS presentation, so I just really liked it. And you actually may see some services that are invoking Lambdas synchronously and asynchronously. And the recent news starts from February this year. AWS announced 3 additional metrics in CloudWatch that will help you to monitor and debug your synchronous applications. So you may find more information about it here, but the greatest idea is that this asynchronous part has always been kind of a gray zone, and we have had no clue about what's going on there. Continuing, I would like to talk about decoupling strategies. And I know there could be hackers telling me, look, you have promised us Lambdas, and actually there is an auto-scaling group. But the thing is that this decoupling strategy and the idea of loosely connected parts is related to literally everywhere and everyone, especially if we're talking about creating a solid and resilient architecture and design. And the thing is that you have here 2 auto-scaling groups being directly connected. So this is something which is called direct integration. And it means whenever there is a load spike on a web tier, the up tier should act responsibly. So it means if you have 2 instances here and there is a huge traffic coming in, so you need to act also here by increasing the number of your instances. But what if this is a sort of application that may actually deal with a small and short delay? So by just simply introducing the SQS queue in between, saying just as a buffer between these 2 guys, you can achieve this independence between these 2. So web tier may increase in its load, storing the messages in SQS queue, and actually it is up to up tier to query the SQS queue and get the necessary messages. By the way, you can not only use SQS in this example, it can be replaced with an SNS, which stands for Simple Notification Service, and we will talk about the differences between SQS and SNS and when to choose one over the other, again, from my humble opinion. The next thing, and again guys, if it is too boring and you have questions, just raise your hand, okay? The next thing about Lambdas is layering. And the idea is, if you remember, I have told you that the size limit for your code package is 250 megabytes, and we're talking about unzipped one. So imagine a situation when you have, like, I don't know, 40 Lambdas running simultaneously everywhere, different structures, but all of them are using your privately written piece of function. For instance, Git module, something that deals with your Git PRs. And the problem is that whenever you need to provide a change, you need to replicate this change 40 times or create some sort of an automation for doing that. So the beauty of layers, that by using AWS layers, it will be just a part of your Lambda function. It will be just as you have copied these files and put it somewhere just here. There is a limitation, as usually because it is AWS. You may have up to 5 layers, and no matter how big or small your layers, the idea is that you still have this limitation of 250 megabytes. Believe me, it is kind of pain in the neck, and that is why I can kind of keep repeating it. Another thing with layers that they are coming natively with versioning. For example, if you have uploaded your layer for the first time, it is assigned with the version number 1. And if you make a change by uploading a new version, succeedingly the version 2 will follow. But you may ask me, given the example I have just showed you, that I have 40 Lambdas, I have provided a newer version, what will happen with the 40 Lambdas continuing to use the version number 1? They will keep working. This is the answer. But the problem is, if you try to deploy a Lambda using the previous version of your layer, it will fail. So this is kind of the logic I'm just trying to share with you. And simply because we have discussed a couple of things from theory, I would like to share with you what we with my team have built on our project. But prior to that, I would like to give you some background of the issue. So our customer uses Kubernetes cluster on AWS, which is called Elastic Kubernetes Service. And simply because they use only one Prometheus pod, it constantly, not constantly, but kind of frequently fails with kills. And stands for out of memory kill. So it usually happens when you have a limit for your pod, and then all of a sudden your pod keeps exceeding this limit. So then, obviously, Kubernetes orchestration just kills this pod. And the thing with Prometheus, this usually happens because of some queries to the Prometheus, because developers using Grafana trying to find some information about it, and voila, your Prometheus is killed. So our team was involved in trying to investigate and provide an automated solution on how we can deal with this problem. So firstly, we did two steps. Because all the valuable information is in Prometheus query logs, we have created a cron job that exports these query logs to the dedicated S3 bucket. Secondly, I don't know how deeply you're familiar with Prometheus, but it is also the matter of metrics and labels. So we have also created an additional cron job that exports related to this Prometheus metrics and labels. So now when you have this in mind, we have created two independent chains of lambdas. So the first one was executed twice a day, and its main idea was just to go to this S3 bucket, sift through the files it has, find the longest queries, and create a simple JSON file with the top, 200 longest queries. And it was done twice a day. Closer to the end of the week, we have the second chain. And guys, for those of you who are not familiar with the sign, it is an event bridge. And event bridge is kind of the AWS service that can send you some sorts of events, walls of life. It may actually filter them out for you. And for us, you may see it here, keep asking me why we have it here. It is a guy who actually can invoke your Lambda by a schedule. And again, simply because I have explained to you the magic of synchronous and asynchronous invocation, event bridge invokes Lambda asynchronously. It means a Lambda may have up to 3 attempts. Okay, continuing with the conversation. This second Lambda, Lambda's chain, which is called PyParsing second phase. Yeah, we are super good at names. So the main idea of this Lambda is just to go here, find all the created JSON files, create a list of unique queries, and send them to this SQS queue. Because this SQS queue is source mapped with this query analyzer, it invokes a necessary amount of the query analyzer lambdas depending on the number of messages you have in your SQS queue. And query analyzers, going back to this S3 bucket, find the files with metrics, labels, analyze them, and if they see something wrong, they just push the message to the next SQS queue. Lastly, and this is actually why I decided to show this particular implementation of Lambdas, you may see here an event bridge scheduling the Lambdas invocation, and here. So between them you have a timestamp, you have a time period of like 2 hours. This test Lambda is invoked. It checks whether or not SQS has something for it, and if so, it creates a file explaining this is the wrong query, and it adds some sort of an explanation. And here actually you have this polling invocation, which I was talking about. So what we have resolved and solved for our customer. So firstly, we help to identify so-called unhealthy queries that were painful for Prometheus because of the execution time. And then they went to developers and asked them to fix them, and yada yada. But another problem was that Prometheus kept using recording rules. So by implementing this solution, which was automatically analyzing query logs on a timely manner, we helped them to identify good candidates for recursive rules, and also keep tracking the use of the existing recursive rules. And just for those of you who are not familiar with the AWS services, I have created this wonderful table. I guess I haven't explained all of them. right? And here goes my question, because coming here, you may see here SQS, why SQS, why not SNS? This is a legit question. The thing is, with SQS and SNS, I personally see SNS, which stands for Single Notification Service, is a way to fan out your messages. When you have different sources, better to say destinations for your messages, this is the right place for SNS. The problem with SNS is it doesn't store your message, it just throws it away immediately. And SQS may actually store your message, and it may store it up to 2 weeks. Yes, SQS goes with two main flavors like SQS standard queue and SQS FIFO queue, and the main difference is SQS standard does not guarantee the order of your messages. It just will try its best to deliver it in the same order. But what's more crucial, SQS standard guarantees at least one delivery. So it means that you may have duplicates. With SQS FIFO, you won't have it. And finally, answering the question of the reason of us choosing SQS over SNS, there is also the beauty of dead letter queue. If you remember, I have been talking about the problem, because here you have SQS byparser, which invokes query analyzer synchronously. And yes, this guy is given 3 attempts, but what if it fails? How will I know? You may create an additional dead letter queue SQS, and it will receive all the failed to process messages. So all the messages that could not be processed by query analyzer will be stored here for me. Why it's important? Simply because throughout the process of development, it was one thing. But when it is in production, we just keep an eye on the things, and we just keep an eye on how well our service is keep doing its job. I keep hearing that there is a huge difference between developing something locally because you have the access to the console, and with Lambdas it is somewhere in the cloud. You have no clue about what it does, and especially how to monitor it. The latter may be not true, simply because AWS offers CloudWatch load groups, and the thing with CloudWatch load groups that they are deployed at the same time with your Lambda. Whenever you deploy a Lambda, the CloudWatch load group is created, and actually the naming pattern will be quite alike with the name of your function. And the beauty is that inside this load group, you may find different streams, and each individual stream will be responding to each individual Lambda's invocation. Simply because we have been talking about with you synchronous invocation and this 3 attempts, all 3 attempts will be written just in this file. Continuing this conversation, you may actually go into log events and customize the search and use it, for example, for ERR, and find all the problems with the code. In addition, I'd like to note that CloudWatch log groups and CloudWatch logs is not the service that could be treated like real-time service. You may experience some delay, so be ready for it. A minute or 2, max 5, but it will be there eventually. And the next idea is with Lambda troubleshooting is to use log insight. So the beauty of log insight is that it actually offers you an SQL-like query, and you may see all the patterns distributed over here and all the files. But what I'd like to motivate you to do with your code, be it production or just your pet project, take a look at CloudWatch alerts, take a look at CloudWatch metrics, because these are your best friends. And this is the list of the supported metrics. Yes, I haven't put here the additional 3 I have been talking about just several minutes ago, my fault. But nevertheless, the most crucial for you will be errors, and you should be aware whenever something wrong is happening with the Lambda. And I believe this is the time for your questions.
could you go back to the slide with this human? Yeah, I have a question about maybe right part, because I think that generally your service that analyzes logs and labels, it's some kind maybe of ETL job that prepares reports as a result. So my question, did you consider AWS services like Glue or Kinesis for this kind of job? Why did you choose Lambda? Because I guess you thought that you have like a pain in the neck with the memory, with it exceeds the memory. Maybe combination of tools could solve this issue.
You know, I kind of disagree with you. The thing with Kinesis is it is destined for slightly bigger traffic. Here, let me explain. Maybe something was wrong with my explanation and confused me. Here I have told you that this guy over here is executed twice a day. So over a week, you will have like 10 files. So it is simply nothing for Kinesis. So this is the problem. But I like your idea, and try always, think big, because it is better, to bring something into a bigger environment than later suffer from insufficient resources or bad patterns designs. Another thing over here, I wasn't sure that Kinesis will help me out with, figuring out what was actually wrong, because as you may see over here, I have kind of a couple of huge files I have to parse and copy. I'm talking about metrics and labels. Then I have only one query over here, and I need to extract all the metrics and labels and compare. Talking about Glue, this is a wonderful idea. Thank you for mentioning. So after we have finished doing all this stuff, the same idea came to one of our team members, and what we have realized that, hey, over here you have your files being chiseled. You have Athena, and Athena may actually help you bring the necessary queries. But simply because today we're talking about Lambdas, I have showed you this solution. But this is the right thing. Thank you. Something wrong with this slide, because actually this guy exports two things. So Excel file for programmers, just open it, and it also exports a JSON file. The difference is for Excel file you have a bigger number of fields, and for the JSON you have all the unique queries for this particular round, and average execution time and the max execution time. And this chain continues over here because it is obvious that, for example, from day-to-day basis, you will have the same queries again and again, over and over. So this guy, I needed just to get all these files and again out of this pretty unique list. So in order not to parse them twice or whatsoever, I just unify them, get rid of duplicates, and then you have this SQS, and then I have a parser just over here. So the parser's idea was just to get into every query, extract metrics, labels, check whether or not this is a recursive group, and move on. Oh, yeah, it is heavy. It is heavy because it is ridiculously difficult to analyze Prometheus queries. So that is why, because our main idea was just to provide some sort of a scaffold for the customer to move on with their own researches. So that is why we decided to do the simplest and easiest task. Extract metrics from the query. It is possible. Extract labels. It is also possible because you know the pattern when they start existing in your code. And yes, the code is kind of heavy. We have more than 400 lines. And once you have these two sides, you can compare it. Because initially what we saw, that many of the developers kept using the labels which didn't exist. And because of this, Prometheus without the label had to query the whole metric against all the files.
What's the execution on this? How much does it take? So, I think long,
For the time.
yeah. Execution wise, time wise.
For one query, it takes less than 3 minutes.
Have you considered using Athena or?
Yes. I can answer. Yes. We ended up with a theme. But the initial idea was, just to show you what's possible with Lambdas.
And also step functions with and parallel would be a really weird thing.
I'm not sure.
It's actually this heavy computation going on. It's something that just not sure that I don't know.
I don't want to talk about it. Let me try to answer.
So, talking about step functions, this is a good thing. We will talk about it shortly. But why we didn't use it over here? Because back then, if you're talking about mapping for step functions, back then the limit was, if I'm not wrong, 40 executions in parallel. Only 40. Yes, it is express, but this is the problem. I could not achieve this express. Because the overall idea, if we're talking about step functions, that everything shall be a step function, not just the small bit. Now you understand. Yes, with the recent introduction of use distributed map, yeah, you have up to 10,000 concurrent executions. Cool.
Oh yeah, you were talking about
Yeah. Okay, we will talk about concurrency later. One more question and we'll move on.
Hey, can you explain a bit more about spin up lambdas in terms of cold starts? So, can I warm up them? I know only old thing. I just can interact with my lambda from Jenkins or CI. Just send a special request and lambda will be warmed up. Yeah. And the second question is what in terms of cold starts if I decided to pack my lambda in Docker container. So basically will AWS starts its container inside these micro VMs, and so basically my lambda will start so it's longer.
Thank you for your question. So the first thing, we will have a dedicated slide to cold start and permission concurrency, where we will be talking about warming up your lambdas and the recently added functionality of Snapstart. Answering the question, between differencing of your container image and just your code. Honestly speaking, all that I know tells me that there will be no difference. Simply because under its hood, what actually AWS does, it simply unpacks your container image, and what's more, because it has layers, they're trying to find similar layers without sharing your security and saving anonymity. And then it is like building the whole operation system using inodes from your container. Because of this, they're able to achieve a very high speed. And answering also this is absolutely the same what they keep doing with the code when you provide just the code. So that is why I'm pretty much sure that it is the same. Also, it may help you to answer this question. Just watch the latest reInvent from 2022. They have a dedicated session for deep dive for Lambdas, where a person actually explains the differences between container-based Lambdas and code-based Lambdas. So that's because we have time limit. I will move on because these guys will kill me. The second problem. So I need to explain you a couple of things first. So we have an Opsgenie over here. And Opsgenie is an Atlassian product that actually helps you to get together, congregate, if I may say so, all walks of alerts from different sources. This is one thing. Another thing here is Atlantis container repository. And the thing with Atlantis, this is just the GitOps way of implementing Terraform. So the idea is whenever you create a PR, you may have a GitHub action, processing it, like simply typing Atlantis plan, and it will be equal to Terraform plan. Then if everything is okay, Atlantis applied and the resource will be applied. This is just for your information. So now let me explain you the real problem. The problem was when I was working in SRE, back then we had a dedicated person who on a weekly basis kept checking the number of user licenses for Opsgenie. This is because Opsgenie is a SaaS and we have to pay based on the number of users who are using it, actually who are registered. This is the biggest problem. And simply because we could find the report provided by Opsgenie telling us which users are active and which are inactive with some caveat, and I will talk about it, we just decided to move around some users. So this is from where this whole automation was born out. So the idea was this, to take Opsgenie's users management report, and based on that and having some inactivity threshold, decide which users we may actually downgrade to stakeholders because they do not get some license. Okay, but there was a problem because Opsgenie users management report covers only GUI interactions. And the problem is that you may actually configure your Opsgenie to your Microsoft Teams and accept, acknowledge, close alerts out of there. And this activity will not be reflected into this report. So for us, it will be looking like you are inactive. So having this all information, this is what we have created. We have this Lambda getting this report from Opsgenie. Then, because we have agreed that we will work with a specific type of users, so we will be working either with single users, just a user does not belong to any team, just a free guy, like I was. And the second type of users will be working with users who belong just to a team, maybe several teams, but they are not a part of integration, escalation, rotation, nothing. Because we decided, just to step aside from this mess. This guy checks all the information, finds, for example, a user who is inactive, but prior to send it to this SQS queue in order to create a PR, we decided to inform first this user through Opsgenie by sending to this user an alert and writing the information about this user's activity into this dedicated DynamoDB table. And after a week, when this function is executed again, if we get this user again, and this user is stored in this DynamoDB table, we know that we have informed them. We gave them a grace period, and they did nothing. Probably they did inactive. Then we send this user to this SQS queue. This user writer Lambda creates a PR, and then this PR is worked over here. So we have described this flow, but there is a problem with users belonging to a team, because I cannot simply create a PR for removing a user from a team and simultaneously to downgrade them, because over here in Atlantis, in GitHub, we have configured an independent workflow treating PRs from teams and users independently. And this means that I simply cannot guarantee that this PR will be worked out, will be processed only after this. Actually, I have no clue about the order. So what we have decided to do, that prior to sending this user to be removed from teams, we will save the information about this user into again yet another dedicated DynamoDB table. Then this PR is processed. And after a week, when we start the execution again, we are checking if this user is inactive. Yes, it is inactive. Then we're checking whether or not it was removed from it. Yes, it was removed. Then we keep proceeding with the already familiar to you workflow. But what if throughout this week, because again, this is a whole week, this user became active again? What are we going to do? So we have a solution for that. Because of the information stored in this dynamic table, we could retrieve it back and send to this rollback teams SQSQ and invoke this team rollback function. So once invoked, this Lambda has all information about the previously user being a part of a team. So it checks the necessary team and understands whether or not we still need to rectify something. And if we still need, then we send this information to the dedicated queue, and the team's writer does the job by restoring the user inside this team. So what we have achieved? First and foremost, the time execution for this Lambda is roughly 7 minutes. We have achieved great automation, which saved us a lot of human resources. Secondly, after implementing this solution for 2 months, we have achieved a cost saving of up to 15%, which is kind of huge. And by the way, during the execution, one of the VPs actually suffered because he was an accident. Okay, I have explained it to you always what's the dynamics again. And because we keep talking about concurrency, I would like to explain it in a little bit further. So the thing with concurrency is that your Lambda is just invoked simultaneously the n amount of times, right? This is cool, but the problem is that you have a limit. And let me explain why you have a limit. The problem is that for the AWS, for each and every customer, they need to prepare the environment, which will be ready for your functions, which will be ready for your Lambdas. And for different regions, these numbers may differ, and actually you may request increasing this quota. And let me step over here and try to elaborate it a little bit further because it can be kind of excruciating. The thing is, imagine please that here I have 1,000 messages, and here I have only 10. Something has gone wrong with my Lambda, and it just sends tons of messages to this SQSQ. And the problem is that all 10,000 of Lambdas will be invoked, and as a result, I may not be sure that these pretty important guys for me will be invoked. This is simply because when you start receiving this error of 429, throttling, you do not have enough resources to move on, you need to do something. And the obvious answer is introducing the reserved concurrency. So we're talking about concurrent executions, and this is actually a metric in the CloudWatch which actually help you to understand what's going on. But what you actually can do, you can put a limit to your function and limit it, let's say, to 100 concurrent executions. What this does, first and foremost, it guarantees that these 100 concurrent executions will be reserved for you. So it means that no other function can bring them from you. Additionally, it guarantees that your Lambda will not get out of your hands by, throttling out with thousands of executions. And you may see here also permission concurrent executions, and I guess this was your question when we were talking about it. So closer to the snap start part, I will cover the permission concurrent execution, but I have mentioned them here just for you. Just understand that reserved concurrency limit will not cost you a thing in AWS. While provision concurrency is something different, because with provision concurrency, you are asking AWS not only reserve the n amount of micro VM instances for your needs, but also to warm them up with your code. Just be ready. Just stay with me, and if it is necessary, I will let you know. This is what you're telling them, and that is why it costs money. And here you actually may see an example from the AWS documentation telling you how to implement this reserved concurrent executions number. So moving on, just a small notice here. I will be talking about solutions provided to me by other engineers. So they may not be, that regular, and I will try to save you time. The first idea over here is that we badly need some solution for certificates management. And here with Lambda, you have a configuration aggregator that actually checks everything from configurations points of view and finds all the certificates that are about to expire in about 30 days and 60 days, informing the necessary teams through SNS topic and directly throwing an alert to HDD. This is a huge. This solution actually shows you how you can implement Lambdas within step functions. Don't worry, we'll be talking about that just in a bit. In order to automate the process of redeployment. So for those who are not familiar with the deployment strategies and deployment process in the AWS, you have the guy which is called the ECR, Elastic Container Registry. And the thing is, whenever your image is updated in the ECR, probably you would like to deploy it in your landing zones, maybe different environments. And the problem is for this particular team that it was absolutely manual, and they kept spending like 2 to 3 hours to implement it. By introducing Lambdas with step functions, they achieved a huge cost saving, reducing this process up, limiting this process up into about 15 minutes. And here you go with the step functions. So I know a lot of theoretical part, a lot of theory over here, but the overall idea with step functions is that I often see that people see them as the only measure to orchestrate Lambdas. It is not so, however, it is partially so. Yes, Lambdas are actually going pretty much well with step functions, simply because step functions may involve tons of resources. Step functions may allow you to execute your functions in parallel, and what's more, a step function may actually trigger another step function. So you may have a chain of step functions, calling one another. And the beauty of step function is that they actually go with 2 flavors. We have discussed it shortly during our short Q&A part. So the standard workflow can last up to 1 year, and this is huge. And the express workflow is limited up to 5 minutes. So generally, the difference between these two is simply this is the cheaper guy, this is the more expensive guy. The expensive guy offers you better execution history, it offers you better execution semantics, where you have exactly one workflow execution, versus express workflows, at least one workflow execution. So you see, maybe duplicates. Continuing this though, express workflow will charge you based on the number of state changes and the length of the memory consumption. Within standard workflows, you will be charged only based on the state transition. So let me move back and explain what the heck is state transition. So the first thing is, and I guess it confuses literally everyone who starts working with step functions, what is the heck is state machine? The state machine is simply workflow. So this is the same. And they also keep talking about the ASL, which stands for AWS State Machine Language, which is actually JSON. So these 2 guys are actually pretty familiar with you. And the state change happens whenever in the step function you are changing your state from one to another. For example, here you have start, then you have one lambda, second, third. You have a logical operation, 1, 2, 3. So overall, you may count here up to 8 state transitions. So this is what you will be paying for. And the beauty of step functions, especially if we're talking about the standard workflow, is that it charges you only based on the number of state transitions, but not the time spent between them. So let's imagine a situation you have here, because here I guess we're talking about whether or not to buy a stock or to sell a stock. So let's imagine here you have an SMS integration which actually sends all the information with all the details to your account manager and asks them, please reply yes or no whenever you can. So the beauty is that you will not be charged for the amount of time you are waiting for the answer for your account manager. So whenever they reply back, you will continue the execution of your state machine. The next thing I'd like to talk about, I guess, oh gosh, almost now, is Lambda Edge. So just to give you some background, we're talking here about CDN. CDN stands for Cloud Delivery Network, and the AWS variation of it is Cloud Front Network. So the idea is it is a huge octopus called AWS, simply occupying the earth. Why it may be necessary for you to care about it in the first place? Imagine a situation when you are delivering a service and this is some sort of a global one. So you would like to ensure that your customers and their user experience is the best around the globe. And the problem is that you simply cannot guarantee the internet quality and latency over the globe. So here goes the AWS with the cloud front, because you may actually leverage the CDN network, and once the user request enters the edge location, starting from that point, it continues to traverse through IP networking using AWS transport. It means that it will continue to transport with the minimal possible latency. And despite its name, because it's called Lambda Edge, actually it is cloud front functions that are located in the edge. And for Lambda Edge, they are located in the regional edge cache. And the thing is, it is a little bit farther from your customers. However, the huge difference between Lambda Edge and cloud front functions, that Lambda Edge may change all these 4 types of requests and answers. And you may ask me, why do we need it? The first one is simply because you may need to change the request or response before sending it to your backend or after receiving a response and prior to sending it to your customer. Secondly, you may introduce this A/B testing, which is, simply the color of your web page, whatever it is. Finally, you may mitigate bugs by using Lambdas attached. So as you may see, there is plenty of implications and there is plenty of various ways to leverage Lambda attached. One of them is still authentication and authorization. And here on this slide, I have a comparison between the biggest cloud providers and analogous options of AWS Lambda. So you may see AWS Agent GCP and the service names, and you may also see that, for example, for GCP, the minimal billing quote is 100 seconds, and you may also see the number of supported languages. And it turns out that actually for GCP they support more. But do not forget for AWS that they offer you to bring your container image, and it usually means that you can bring your own programming language. I mean, the one which is not listed here. Moving on, as I have promised, we will talk about the execution environment lifecycle. So the idea is, we have already talked about it a little bit, that it is up to micro VMs and actually up to your code or container being unpacked and delivered to this micro VM environment. And these actually are the stages that can be rounded up by cold start. So when actually a cold start happens, usually it happens when your Lambda is invoked for the first time, or it is invoked for the first time in this particular environment, which was not ready for you. Of course, for different languages, I'm talking about programming languages, you may have different time expectations for the cold start. Especially this is a problem for Java, because for some cases it may take up to 6 minutes, and given the criticality of your operations and criticality of your Lambda, it may be pretty much sensitive. And we will talk about the solutions which AWS offers, but the solution which was known up to the latest reinvent was the provision concurrency. I have already slightly touched it. So the idea is that you give to your particular lambdas, just the one lambda, the provision concurrency, for example, 10. And it means that you have 10 environments already finishing.
Certified.
35, I didn't know I had something.
Yeah.
Okay. So the thing is that for provision concurrency, you have already environments finishing at a cold start, and they're just here waiting for you. So, ta-da! This is the new thing, which is called Lambda Snapstart. The idea with the Snapstart, coming back here, that if we're talking about a micro video, what if we can do a micro snapshot? So just over here, after function init, we will make a micro snapshot, and when a succeeding Lambda's environment will need to continue this execution, we will just provide the snapshot and the Lambda will be restored just from this snapshot, saving you a lot of time, simply because it is possible. And of course, as usual, there are some limitations. For now, it works only with Java 11, which is Coretta, and this is the biggest thing. If you are not using your Lambda for consequent amount of 2 weeks, just 14 days, this snapshot will be deleted. So it means that during the next invocation, this snapshot will be taken again, but nevertheless, you will wait. Compatibility issues. We have been talking with you about ephemeral storage, so it is not supported, so you need to have only 512 megas. Elastic file systems, EFS, no. Provision concurrency, no. And this is actually what AWS recommends. They actually taking the precedence, and they're telling us that provision concurrency is what we think should be reserved for your critical executions, and Snapstart may be used for the standard ones. And unfortunately, it is not supported with the use of Rabbit 2. Pricing, it is free of charge. And this is the current availability for this functionality. And I guess this is the second finishing and wrapping up the Q&A session.
Probably a question from me, like a software engineer. Is it kind of out of the box, so our code doesn't need to know anything about this warm start and just work out of the box? Or
The short answer is no.
so we need to implement in our code something.
No.
So basically, if function only executes once, it uses warm startup every time, right?
Yes, no.
So you're talking about the situation when you have your Lambda and you have, let's say, a reserved concurrency of only one, right? So, and what you're thinking about it, like scheduling mechanisms, it's pretty familiar and pretty similar to Kubernetes scheduler. Your function will always be routed to the same environment, which is not always the case, simply because you are not using the provision concurrency. You are just executing Lambda, and AWS guarantees you execution, but not the execution on the same environment each time. So the answer is yes, it could be, and no, it could not be, simply because no one guarantees it. Does it answer your question?
So it does depend on the frequency.
Yes and no. Talking about the frequency, again, usually what AWS tries to do whenever your Lambda is succeedingly finishing something and there is a consequent execution of it, so they will try to reroute your function to the very same environment, but they cannot guarantee.
So basically, what I mean is in Azure, we have Azure functions, and you have And if you set it to cold start, it always start with the creating of the micro VM and yes, and on the warm start, it keeps the micro VM running. So at minutes, so in the AWS it depends on the preferability, right?
Yeah.
Again, until you are not using provision concurrency. Because when you use provision concurrency, yes, you have a warm up environment ready for your execution. Yes. If I'm talking about, if I may say, call it so free tier, no. It really depends. It may be routed to the very same environment, which is already kind of warmed up, but it may not be. Good? Guys?
Just an addition to that, step functions have a feature called exponential backup cache. Exponential backup. That's also a state transition, and very cool feature of step functions is different kinds of integration. For Lambda, they have wait for fast token. That actually flexes your Lambda answering period. So you can make this kind of a asynchronous call and externally.
Wait for the token and then
Yeah. So there was still functions you can see.
Yeah, guys, this is actually a good point. This is something I have missed out. Thank you so much for mentioning it. So we're talking here about step functions also having the possibility to back off. So, for example, if there is a throttling, so you may just pause a little bit, wait, let's say 2 seconds, and then move on. But again, this is a backup, so you can set the limit of the max number of attempts because when you really just finish it by throttling. Or you may back it off by increasing the small pause, let's say 2 seconds, increasing or multiplying it 2 times each time. Cool. Any other questions, guys? If not, I would like to thank you for your patience.